Hello, everyone. Thank you for joining us for today's Caringo Tech Tuesday webinar. This session's topic is using Elasticsearch with object storage. I'm Sarah Cook, Caringo's Director of Marketing. Today, I bring you not one, but two experts. We have with us John Bell, our Senior Consultant, who most of you will know from prior Tech Tuesday webinars. And we also have Senior Engineer Jamshed, or as we call him, Jam Afshar. John and Jam will be available to answer your questions throughout the webinar and also at the end of today's presentation. We also have a number of resources available via the attachments and links window on your view screen. If you have any questions after the webinar, you can always reach us by email at info@caringo.com. So as we get started, John, would you share a little bit of information about yourself with our audience?
Certainly. Thank you, Sarah. I've been with Kringo for over 7 years, and I'm a senior consultant based in Austin, Texas. I specialize in the design, implementation, and management of object storage, and I've worked with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions. Jam, please go ahead and introduce yourself.
Hello, folks. I am Jam. I'm a software engineer at Caringo. I've been here almost 10 years. I've had various roles in engineering, consulting, and support, and I'm currently working on Swarm and containerization.
So before we get started on our topic today, for those of you who are not familiar with Kringo, I just wanted to share a little bit of information. So our company was founded in the year 2005 with the mission to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Kringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Kringo software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Argonne National Labs, the UK Science and Technology Facilities Council's Scientific Computing Department, say that 10 times real fast, Texas Tech University, that's a little easier, the US Department of Defense, the Brazilian Federal Court System, British Telecom, and hundreds more worldwide. So without further ado, I will bring you to the agenda and turn you over to John Bell.
Very good. Thank you, Sarah. The supercomputing is always the toughest to pronounce because it's the most complex. Very good. Okay, folks. So just quickly here, we're going to walk through an agenda of what Jam and I will be presenting today. We'll start off with a very brief overview of object storage, specifically with a focus on the relationship of data and metadata within object storage. Then we'll dive into an overview of what we call the swarm search pieces, which is where the Elasticsearch component comes into play. We'll discuss the hardware requirements associated with that, the overall infrastructure requirements, all the pieces that come together to allow for this list and query capability within Swarm storage. And then last but not least, Jam is going to be demonstrating to us how that works on live system. So let's talk a little bit about object storage and specifically data and metadata. In terminology that Caringo uses for Swarm storage, when we talk about an object, we're not just talking about data. You know, like for example, a spreadsheet that was stored, or a PDF, or a backup file, or a VMDK, or anything like that. When we talk about an object, it's a full encapsulation, not only of data, but also the metadata, the describing characteristics of that object. And they are all encapsulated and stored together within Swarm storage. And as a result, both the data and the metadata are protected within Swarm storage using the same protection scheme. This allows us to have very good data resilience, not only for the data itself, but also for the metadata characteristics associated with it.
So John, we have a question from the audience. So is the metadata stored with the object in all object storage systems, or is that unique to Swarm?
It's unique to Swarm from what we've observed. There are a lot of solutions that are available in the market today that tend to separate their metadata stores. They typically store their metadata, in a separate database of some kind that's basically, uncoupled from the actual data itself that's stored in what they would term to be an object. We found, just in design and in practice that opens you up to a lot of issues when it comes to access to metadata. You have this completely separate store that you have to back up and manage and keep track of. There's always the opportunity for metadata associated with an object to become out of sync with the object itself. We've just found that our approach is a lot better in practice to just encapsulate and protect and associate as an object both the data and the metadata within the storage system. It allows for a lot of simplification in areas such as site-to-site replication, feed design, and so on. Very good. Any other questions, Sarah?
None that have come in. I want to remind our audience, if you have questions and you don't get them in today's webinar, feel free to always email us at info@Caringo.com. We will make sure that somebody like John Bell or Jam gets back to you with an answer.
Very good. Thank you. Okay, so now that we have a concept of what we term to be an object and data and metadata associated with an object, let's dive into some Swarm Search overview. So what does Swarm Search provide for you? Swarm Search is there to provide what we call actionable insight into the objects or the data that you stored within the system, and basically lets you perform targeted analysis on what you have in place. It's what we call finding the needle in a haystack of a very large pile of unstructured data. So not only does it help you in finding what you're looking for, it also allows you to build up relationships for all these disparate pieces of information that you store within the system. And those relationships are basically built up around the metadata characteristics of the objects. And that goes into areas such as dynamic organization of content, classification, keywords, descriptive content. This is what the metadata does for you and provides you with multiple ways of tracking that content within the system. As a result, there really is no separate big data project required. A lot of this metadata relationship analysis list and query is self-contained within the storage system within Swarm itself. So what do you need to provide this capability to run this? The Swarm Search hardware requirements are bulleted out below. We support running Elasticsearch on either Red Hat Enterprise Linux or CentOS 7.x. That's where Elasticsearch would run on what we would call the indexing servers. These machines can be physical or they can be virtual machines, and in fact, for the vast majority of deployments that we have in the field running in production to date, the Elasticsearch farms are running as virtual machines. So there's nothing preventing you from doing it that way. In general, we recommend that you have 3 servers to provide full redundancy and high availability for the Elasticsearch farm. 5 is ideal, especially so for large deployments where you're going to be storing a very large number of objects. Each one of those servers typically is going to have a multi-core CPU of some kind. Usually 4 cores per server is a good starting point. They'll have anywhere from 32 to 64 gigabytes of physical memory. Those of you who are familiar with Elasticsearch using it in other areas know that Elasticsearch is very much a memory-driven application. It likes to have a lot of physical memory. So it's no different here. It's Elasticsearch and it needs a lot of physical memory to run. And then for the shard information, we recommend that you have anywhere from 500 gigabytes to 1 terabyte per server of SSD drive sitting underneath that. And the sizing drivers that are involved that bring those specs to the forefront are the number of objects you're going to store in the system and the amount of custom metadata that you're going to be associating with each object in the system. And when we size for this, we tried to be fairly conservative, and in our recommendations, we're accounting for a very large amount of custom metadata per object when we come up with these specifications. So if you have any questions around, specifically how we go about doing that, please let us know. But those are the two sizing drivers that we take into account. Any color to add to this, Jam?
No, that sounds good. The main thing is just to make sure you have a good amount of memory. Don't skimp on the memory of Elasticsearch, because that improves its speed very much also.
Right. And there's a heap driver there as well, isn't there, Jam? There's only so much heap in Java that you can use before performance degrades, which is why we dial in on that memory count per server. It's max heap of 32 gig. Is that correct?
Correct, right, because that prevents Java from being inefficient with pointers if you max it out at 32 gigs. And also importantly, Elasticsearch relies very much on the operating system file cache. So you want to leave the rest of your RAM to your OS for that.
Right. Very good. Thank you, Jam.
Sure.
Okay. So I believe we've talked about this already. So let's talk a little bit about the swarm search infrastructure, all the pieces that you need to have in place to support this capability. You're basically going to need to have a combination of swarm storage, where the objects are put in place. You're also going to need to have an Elasticsearch cluster, as shown there in the diagram. The swarm storage cluster is going to be configured to point to that Elasticsearch cluster with what we call a search feed definition. And what that does is it tells Swarm that this is the target where you want to send all the metadata information associated with your objects for caching into the Elasticsearch cluster for high performance list and query applications. And what happens is that client applications will come in with what we call an extension to our SCSP protocol, which we call SCSP Plus, Simple Content Storage Protocol Plus. And it allows for extra query args associated with doing list and query of metadata characteristics of objects and bringing back result sets based on the API calls that were made. Anything you want to add to that, Jam?
No, that sounds good. It's, yeah, no, I don't have anything to add to that.
I think one thing
Jam,
go ahead.
Can the Elasticsearch be backed up to the Swarm cluster?
Yes, I'm sorry. Yes, it can be backed up, which is, so first of all, understand that you don't rely on Elasticsearch. None of your metadata is only stored in Elasticsearch. It is, so you can always recreate it, like if your Elasticsearch farm blows up, you can always re-index everything because metadata is stored with the object in Swarm. But of course, that's problematic if you, in terms of recovery time. You know, if you lose your Elasticsearch database, then you can't do listings. So what you can do, though, is you can back up your Elasticsearch database to your Swarm to make it easier, or to make recovery much quicker. So you can just periodically snapshot it, and I can bring up a document or documentation that talks a little more about that. But you can periodically snapshot your Elasticsearch database and then restore if you ever lose data, or you lose all your Elasticsearch drives. And that way you can have your listings back up and working quickly.
This might be the first time I've heard somebody say your Elasticsearch farm blows up. Does that happen very often?
It's been, not so much with recent releases, but it has happened. If it not literally blow up, of course, but definitely if you run out of memory or something, older versions didn't handle that well and would sometimes corrupt. You shouldn't run into that anymore now that we're on Elasticsearch 5. But it's always good to to back up your any database, whatever it is. because you will find that people rely on these listings, and if listings are down, they will consider your swarm to be down.
Yeah, that's true. I would also add to that, Jam, that sometimes Elasticsearch farms are misconfigured. And you may run into a situation in the field where, say, they only have 2 Elasticsearch servers. And in that type of scenario, you may run into a split brain Elasticsearch as a result, given the way masters and slaves are set up to talk to each other. And so typically, of course, what we recommend first and foremost is people run 3 or more Elasticsearch nodes to avoid that situation. But if it can't be avoided, you can basically drop all the data in the Elasticsearch farm and then restart the feed to have it reconstituted in Elasticsearch so that the split brain issue goes away. And we've had to do that a couple of times for small deployments, and that's typically only where you see it as very small deployments. I would also add, we support the ability to have multiple Elasticsearch feeds configured in Swarm storage. And this comes into play with Caringo's overall approach of an always up goal, always being available to the clients. So if you're in a situation where you're performing an upgrade of Swarm, and it turns out that you also need to perform an upgrade of Elasticsearch to support the latest, greatest Elasticsearch that we ship with that version of Swarm, what you can do is you can turn up and enable another search feed, point it to the new Elasticsearch farm that you've brought up that's running the newer version of Elasticsearch. And then when you're ready to cut over, you make that new version of Elasticsearch the primary search feed. And what that means is that any list or query requests that come in will start pointing to that new Elasticsearch farm and stop referencing the old one. And at that point, you can decommission the old one and move on. So having that multiple search feed capability to support different versions of Elasticsearch at the same time for upgrades makes migrations a lot easier.
Yeah, it's always nice when you can say you're doing a major upgrade without having to have any downtime, and that's what that provides.
So that pretty much covers Swarm search infrastructure. Let's move on to your demo, Jam. We're just in time for your demo. So I'll go ahead and hand the controls to you.
Excellent. All right, let me set up the screen share. Okay, are you able to see the screen?
Yes, I see that just fine, Jam. Thank you.
All right, excellent. Okay, so for the demonstration of Kringo, Elasticsearch, and metadata, what we're going to do is upload some objects into Swarm, tag them with metadata, and then show how our collections let you search on that metadata to present the data to kind of like filter down and find the objects, the needle in the haystack that you're looking for. Okay, so first let's create a bucket in which to place all our data, or to place our files. And then I will start dropping some files in here. Sorry, I'm going to drag and drop them. I already have the window open.
And while Jam's doing this, I just want to point out for the audience, this is actually not a demo system. This is our corporate Swarm storage in action. We're actually running this on a live production system. So everything you see here is basically what we currently ship.
Yes. Okay, so what I'm doing here is I'm uploading some cat images and videos. Now what I'll do is I will tag them with metadata I'll name this is going to be stored as a header on the object. The format of our metadata is x dash and then whatever you want and meta. And let me put in the value of cat. So all of these objects that I'm uploading are videos or images of cats.
Oh, so that metadata format you're using, it's like x-star-meta-star, right? Anybody that wants to make
Correct.
custom metadata, that's the format that they would follow.
Exactly, yeah. So now when we go into the bucket, we can see the objects are all in there. Now let me upload some more, some dog videos and dog images.
Yes, we want to give fair time to the dog lovers in the group.
Yeah, that's right. I'm going to skip the otter people, though. Sorry about that.
Okay. I think that's fair.
We only have so much time for this demo. All right, there's a few more of these, so this will take a little bit more time. But this is really nice, a nice feature of our portal, that it makes it very easy to upload files that you have in your system locally, and you can easily tag it as the data is going in. That's the important thing about metadata tagging and swarm search, is that you need to be able to tag your objects either on upload, or you can do it afterwards. We have a simple call to let you add metadata after the object, if an object already exists in your system. So now once you have all these objects uploaded, you can see them here. We can see down here the X animal meta data is there with the value of dog. All right, so now what we are going to do is create a collection. So that is basically like a saved search. We're going to restrict it to the demo bucket, which I just created. And then we are going to decide on which one. Let's search for cats first. Okay, so I press the refresh button to attempt the search first. So now that is what we're trying, these are the images we're trying to find. So let me save this.
So Jan, where are you saving the collections and the queries to?
Oh, okay, yeah, I can show you that. I have that up. So this is what the cats collection looks like. You can see that it only found the objects in the demo bucket that were tagged with cat. Okay, and to search on these are all stored via our management API in the gateway, and you can see the collections here are available via listing on this path, so you can curl that path. You can do a curl post to create your own collections, so you don't even have to use our portal UI in order to do it, though it is convenient. But you can use the collections feature in your own applications, and it's very simple. You just post a object, some JSON to this URL. This is an example of what the JSON looks like.
So they're stored as JSON code?
Correct. It's stored as, our queries are in the JSON language, and it's just a pretty simple format with a name, which fields you want the collection to show, and then what the query that you want to do. So these can get more complicated. You can have like ands and ors, and you can also search on other fields, like say the content type of the object. I'll show that. So let me do a dog collection.
And to elaborate on what Jam said while he sets up the dog collection, the admin domain is something that is stored in Swarm storage. So what that means is that these saved queries are stored and protected in Swarm storage with the same global protection schemes that regular object data is stored with.
Exactly. now if we decide like, okay, instead of a dogs collection, what I really want to see are only the dog videos, you can just add another item to your search criteria. This one will be the type of the object. And we'll just search for all videos. And now when we refresh that, we can see that it's only the MP4s that are being returned. Only the things tagged with video MP4 are being returned. And I can save that as another collection called something like dog videos. So the great thing about this, and it is that it's sort of like a pseudo bucket, okay? So you go into the collection, it looks like it's listed in the same screen under your domain as like a bucket. We also have collections. You click on the collection and you see this being added. And it's dynamic. So as you upload new objects to your bucket, so I could upload new objects here, and it will, as long as you tag it correctly, the collection will be live and will show that new addition. And this is a really great feature, collections. We use them all the time. There's some standard collections like last 24 hours, uploaded in the last 24 hours, or 7 days or whatever. Those are easy to create and they're very useful. And another example of where we use them is when you submit support tickets, problems, and you upload your like log files. Those are tagged, of course, with your customer name, and they're so that we can make collections. Like, we can make collections of a particular customer's log files, and it will find all the ones that they have uploaded because we tag those when you upload them to a support ticket. Yeah. So that's just an example of how we use it internally. It's very, very useful. I'm sure that as you start using it, you'll find many cases where you want to add some tags to objects that you upload, and you'll want to build collections to make it easier to find those later.
And I think another key here, Jam, is that usually when people are faced with this problem to solve, the first hurdle they have a hard time getting over is, oh, good grief, what conventions am I going to use for custom metadata? I don't know. I don't know yet. That could be a big project in and of itself. But the magic of this is that you can add or even change custom metadata on the fly within our solution. I believe the underpinnings of that is a copy operation, but regardless of that, you could just mock things up quickly within our solution and kind of demonstrate how it would work with a proposed custom metadata approach. And then if somebody wanted to change that later, you could just go into these objects later and add or change custom metadata as necessary, and then they would show up in the new collection scheme that you wanted to use.
Exactly, yeah. And
there's a lot of solutions out there that are not nearly that flexible with their metadata, but in our case, we're extremely flexible with our custom metadata.
Yeah, the ability to add afterwards. You don't have to re-upload the entire object. There's a simple command to add metadata. So that's really nice. I was just going to do a quick demonstration of how this collection, I will add an auto video just to show the live update feature. So there's nothing being found right now. But if I go in and add a video, add a otter file.
And we had a question come in from the audience. This might be a good time to address it. And the audience member asked, can you force require tagging to upload so that no untagged data is uploaded?
I'll tackle the
question. Sure.
Go ahead, Jan. If you want to tackle that, that's fine.
Yeah. That's a good question. We don't have a way to automate in the portal. There's not anything that requires it to be done. But that would be a pretty easy feature to add. But also, if you probably have a way that things are submitted into your object storage. I don't know if most customers, like the end users, use a portal to do that. But if you have your own custom way for objects to get into your storage, you can, of course, add that there to require it to be done. Now, we do have a feature where you can automatically tag things that go into a bucket with things like the upload time and with a fixed set of metadata. So that you can do to automatically add some static sort of metadata entries.
Isn't there a metadata transform, metadata exform capability as well, Jam?
Right. Yeah, that's the one that I was talking about. That it automatically tags metadata as it's coming in with some fixed metadata.
And that's something you can set up for like a domain or a bucket ahead of time. Is that right?
Correct.
Yeah.
Yeah, you tag that on the domain or the bucket.
And can you avoid having redundant meta tags?
The names are unique for the metadata tags. You can have only a unique list. You can add like multiple entries to XAnimal, for example, that XAnimal meta. You can have multiple comma separated entries to that.
Right, and I think that's the question, isn't it, Sarah? Can you require a current tag or metadata, custom metadata to be applied so you don't end up with two custom metadata entries like dog and dogs? And I think you just answered that, Jam. You can have it comma separated for just a single custom metadata entry, right?
Right. Okay, so I just uploaded a otter GIF, and that was able to that caused the collection, which was previously empty, to have this one entry. And it doesn't. I thought the image would come up here, but I guess it's just over the file size limit where we auto preview. But otter dancing is really there. Okay, so that was what I wanted to demonstrate for collections. If we have any questions about that, I can take them, but I also wanted to, I pulled up the documentation we have on how to back up and restore Elasticsearch to Swarm so that you can minimize any downtime that you have. So this is just in our documentation.
So Jam, we're not seeing that on the screen, just so you know.
Oh, I'm sorry. Let's see. I think maybe it only shows the one tab. Is that right? It only shows the portal tab on your side?
That's what we're seeing, yes.
Okay. Let me see if I can change that.
It's always fun when you do a live demo.
Yes.
And if you need to, Jam, you can stop the screen share and jump back in to get the settings you need. But the point being is,
can you tell me does this show up if I put it into the same tab?
There we go. That we can see.
Oh, cool. Yep. Okay. Sorry about that. I thought it would show the whole window. But here is our documentation on how to snapshot and restore the Elasticsearch database. And it's pretty nice. It's very simple. Elasticsearch has this feature where it backs up to an S3 or S3 compatible system. And that's what Gateway does. So you basically just configure a plugin within Elasticsearch. This shows the example of what to add. This is all just standard. This is from the Elasticsearch docs or from the AWS Cloud Plugin docs. You configure the S3 repository. So that's going to point to your Swarm cluster, to a bucket within your Swarm cluster. And then you run a snapshot command to create the backup. You can verify that the backup was there. So you would do that. What you would do is you would run this periodically, just like any database backup that you have. And then if you ever lost your Elasticsearch and you want to restore it quickly, you can restore the snapshot we give an example of where you delete all your Elasticsearch data, but you can quickly restore it using a simple command, and it will read the backup from Swarm back into your Elasticsearch cluster, and you'll be ready to do listings again. So I've always liked that solution.
4 fairly easy steps, right?
Exactly, yeah. It's just configure the plugin, the Snapshot plugin, does a periodic snapshot, and then you can do a restore at any time. And it's the nice thing about these backups too is that they're of course efficient in terms of space. They only, when you do a snapshot, it doesn't repopulate everything, or it doesn't back up everything if it hasn't changed. It only backs up the new things. So that makes snapshots a lot faster as you go along.
So basically, we present customers with 2 ways of doing this. This is the fast way, and then the other way, of course, would be to drop the Elasticsearch data and then restart the feed from the Swarm side. That just takes longer because Swarm has to iterate through all the objects to populate Elasticsearch.
Correct.
Yeah. Very good.
All right,
Thank you, Jam.
Sure. The last things I'll show are you had asked about where to find the collections. So it's just a simple API call or you can just curl this URL. It's stored in our Etsy documents, which are just documents that are associated with this domain, my jam.cloud.kringo.com domain. You can see down here the otters collection and the cats and dogs collections.
Mm-hmm.
So if you bring it up here, I'm listing specifically the cats collection, and you can see that these are the fields that will be displayed for that collection. You can add your own, like if you have other custom fields, they can be included there. And this is the actual query that gets performed. It's an AND operation, so you can list multiple objects. You can also do OR. And this is the metadata that it's looking for. So I just wanted to show you that the collections that I just created in the portal UI, there's no real magic there. It is just this JSON object that gets uploaded into Swarm.
And I'm noticing here, Jam, since this is our corporate cluster, you don't require any kind of administrative privilege to manipulate collections that belong to you, or to even view them for that matter. Yeah.
Exactly, yeah. I don't have any special privileges. I'm not an admin on here, but as long as you own the domain or have write access to the domain, you're able to create collections in it.
And the neat thing about this, for those in the audience, Jam demonstrated a lot of this being done through the portal. You can do this programmatically using our API as well. So if for some reason you needed to batch this out for a group of people, there is a way to provision this in a batch fashion if you wanted to have them, come online with their assigned domain and a specific set of pre-canned collections that you wanted to give them access to.
Exactly, yeah.
Very good, Jen. Did you have anything else for us?
No, that completes the demonstration. I'll stop sharing and turn it back over.
Excellent. Good stuff. Thank you. All right, Sarah, I'll give you the wheel. Take us to the finish line.
Okay. Well, John and Jam and everyone on the broadcast, thank you so much for joining us today. You can keep up with Kringo by following us on Twitter, LinkedIn, or Facebook. And if you have additional questions or you'd like to schedule a custom demo, always feel free to email us at info@caringo.com. And I'd like to invite you to join John Bell and our VP of Engineering, T.W. Cook. And note, there is no relation, despite the fact that we do share the same last name. But for our August Tech Tuesday webinar on August 20th, and in that webinar, they will discuss data resilience and recovery in Swarm object storage. So, thank you so much, and we look forward to seeing you back for Tech Tuesday next month.
Great. Thank you both.
All right. Thank y'all, folks.
Thank you. Bye.